Met Office. Today, I'm going to firstly to explain some context, explain a little bit about who the Met Office is, and then I'm going to examine what technology means for the Met Office so that we can go on to talk about what technology may or may not mean now and what it may or may not mean in the future in the context of a changing enterprise. So launching straight in, a little bit about the Met Office. The Met Office's purpose is to help you make better decisions to stay safe and thrive. For those that are based in the UK or are familiar with the role of a national meteorological service, the Met Office is one of those, and that's doesn't mention weather forecasts, it doesn't mention climate research. So our purpose is all about actually enabling decision making as opposed to the generation of forecasts. We are, of course, part of UK government, and to that end, I'm a civil servant. We're also part of an international community of 191 or so other organisations that broadly do the same thing, the same kind of work that we do. We're a world-leading science institute, particularly in climate research and weather forecasting. And finally, we are to some extent a commercial business as a function of being a traded fund for the UK. So those four things mean that the organisation is somewhat complex. Some might say more complex than it needs to be, but nonetheless, it's a complex organisation and therefore has a complex and sophisticated technology estate. So let's go on and talk about a little bit about technology. This is a picture from the early 50s when the first real computers, Turing-compatible computers as we would recognise them, came into play. And this is two instances of a Ferranti 1 machine, one of which was the first machine that the Met Office had back in 1958. These days we run, as you can imagine, on very cutting-edge technology. So this is the current Cray XC400 implementation that we're using, and that is one of the largest supercomputing platforms in the world and is the largest dedicated to weather and climate work. But as you'll also appreciate, without knowing, the supercomputer is not all the IT that we need in order to fulfil our mission, and I'll come back to that. So what's the driving factor that the Met Office has seen, which, if it hasn't already come your way, will be coming your way? Now, not very long ago, I had to explain the human impact of exponential change, but given the unfortunate effect of a global pandemic, I don't think I need to go as much into explaining what exponential growth means as I may have had to do 6 months ago, which is both a good and bad thing. So this plot shows Met Office overall computational capacity on a linear scale for the last 70 or so years. And what those numbers are doing are faithfully doubling. But of course, because it's exponential growth, you only see that big inflection in 2010. And that's the point at which people like researchers at McAfee, at MIT, for example, talked about the second half of the chessboard. This is the doubling of big numbers. So an intrinsic part of exponential growth, as we all now know, is that at some stage you cease to double small numbers and you start to double big numbers, and that's where exponential growth gets challenging. And certainly the Met Office is representative of few organisations actually that are now genuinely doubling big numbers in terms of the scale and complexity of the IT that it operates. So what does that IT look like? My enterprise architects call it a sedimentary architecture, into which they do some geology to understand how it works. So what that really means is the organisation has been exploiting technology for, as I say, 60, 70 years at scale. And the result of that is layer upon layer upon layer of cutting edge technology when it was first put in that really has had little thought and attention put to it since it was. So this is a street post in Mumbai and represents every generation of telecommunications that has ever existed. So you've certainly got copper lines in there that will be serving telex machines or sending on the wire IP protocols or something. And at the same time, you'll have the very latest fiber optic high-speed communications link. The point here is that everything coexists one on top of the other, and to some degree that very much represents the architecture that we inherited sort of 5 or 6 years ago before we started our transformation mission. So if only our architecture was neat and tidy, but that's a key part of understanding how to effectively do transformation on that technology estate, is to find a way, arbitrary or not, to classify it such that it can be that one big problem. Some people use the metaphor of eating the elephant, can be broken down into a series of parallel activities. So to do that, we've broken our architecture down into 3 chunks. So firstly, there's a science IT estate, so that's where the supercomputer sits, a lot of the research tooling. NWP stands for numerical weather prediction, which is the jargon applied to the computational science approach for weather forecasting. Observations, clearly you can't predict the future of anything if you don't know its current state, and so there's a massive observations program, a global endeavor indeed, whereby satellite observations, atmospheric observations, land, marine, are all used to initiate the simulation process. Mass storage systems, so the Met Office currently has a contract mass storage of over an exabyte, of which we deployed about 280 petabytes, so massive amounts of data being stored. All that data needs to be analysed, so analytics tools, and obviously the operational meteorologists need forecasting tools. So they will sit in that clutch. Next, we have things that will be more familiar to all of you. Essentially, what this clutch of infrastructure is doing is taking the data that flows off of the supercomputer and turning it into useful data that can be exploited in products and services. It generates some of those data products. Obviously, networks and different forms of storage are in here, as are front-end desktops and all the things that any organization will be familiar with in terms of customer relationship management, content management systems, in our case, Office 365 for productivity, HR information systems, and so on, ERP, and so on and so forth. And then finally, there is a clutch of IT that's all about delivery. It's all about what the customer sees, and they're typically websites, although less and less so, increasingly apps, and even more increasingly now APIs, application programming interfaces, or data services of some description that are used as the vehicle to deliver our last mile services to customers. So if you like, that's the environment. To go back to a more simple picture of that 3-layer model, we've effectively already decoupled part 1 from parts 2 and 3 in such a way that we can work on them in parallel, and I've not got time to go into the detail of that today. However, the second 2 bits, for the last 5 or 6 years, we've been transforming in public cloud infrastructure, and at the same time building a case and justifying a new approach to scientific IT in many areas, and that's underway. Now, importantly, and we term those the create and exploit environments, but important to recognise that all three of those areas deliver independent value of their own right. So, for example, the science IT, as a world-leading science institute, is supremely important in its own right, so that our scientists, of which there are many, can publish papers and get involved in global scientific research. So that in its own right delivers value, as does our enterprise IT and as does our digital IT. However, obviously, there's also a value chain that flows along them when you think about the Met Office as a forecaster. So I'm going to skip over this slide because I'm a little short of time, but there's been a significant change in how weather forecasts and simulations and predictions get manufactured as a result of more competent and capable IT and more capable science. So this is an automation story, but that's not going to be the focus of today. I want to instead move quite quickly on to thinking about some of the nouns that are used around the industry. So we'll start with information technology. You can read the description, standard dictionary description, and some of you will have roles or approach your job in a way that's what you do. It's about the bits and the bytes. It's about the computers and the infrastructure. It's about storing, moving, creating data, that kind of area. Some of you, and I would put myself into this camp, instead would see yourselves as technologists. And technologists means something subtly but importantly different. So this is the application of scientific knowledge, the creation of new things. My own personal favourite definitions are these that you can see. So Douglas Adams, who's the author of The Hitchhiker's Guide to the Galaxy, which I love, defined technology as something that doesn't quite work yet. And Alan Kay, a more renowned computer scientist, technology that wasn't around when you were born, which has recently been updated to technology that wasn't around on your last birthday, to demonstrate this exponential increase in speed. So the point here is that all too often, and even at the highest levels, assumptions of what technology looked like in the past are extrapolated, I would question, sometimes inappropriately, into the way it's going to work into the future. And given this exponential growth and given this exponentially accelerating phenomenon that is technology, that's a very dangerous place to be. Even taking things that worked a few years ago and saying, well, they've done us well for the last few years and they therefore will into the future, can be a difficult business. So some of the questions that flushes out for people that may be watching this broadcast would be technology. Is the approach of you and your organisation, is your organisation's understanding of your role about the introduction of new things into the organisation, things like innovation in technology terms, machine learning, blockchain, autonomous vehicles, those kinds of things? Or is your job information technology, i.e. using bits and bytes and systems and IT to support the organisation? Because those two things are fundamentally different, and I hear them cross-talked all the time. There are plenty of titles out there. They change all the time, and they can variously mean either one or both of those things. So there's no sense there. Similarly, when we get more technical and we talk about IT, I think the dirty little secret that's always been there for IT is actually IT can be broken down into some very straightforward primitives. IT really means the ability to compute, store stuff short-term or long-term in memory and storage, and move stuff about via networks. And you can only really do those things with data or with programs or functions or algorithms. So that one slide encapsulates everything that's possible with information technology in some way. And indeed, when you talk to the high-scaled, as they increasingly term the hyperscalers, the big public cloud vendors, that's the level of analysis that they use to talk about the future of technology. They really don't talk much about stacks. They don't talk much about operating systems or storage metaphors. They really start off with these primitive level conversations. Similarly, we can talk about cloud. And cloud can mean many different things. Cloud could mean on the left-hand side as simple as somebody else's infrastructure, to on the right-hand side genuinely transformational capability of ephemeral compute, or serverless as it's commonly known, whereby the model of exploiting and making use of IT is actually completely abstracted away from the IT itself. And of course, none of these things are right and wrong. All options have a place. The call to action here is to be clear about, when we use words like cloud or digital or technology, what we actually mean, because the assumptions of just winding assumptions of what these nouns may have meant maybe 10 or 15 years ago into the future is a very dangerous place to be. So does any of that kind of introspection on the definition of nouns mean anything? Does it matter? Well, not really. And this certainly isn't about me or anybody else being arrogant or naive enough to prove that a given noun means a certain thing. But in your context, in your organization, whatever that may be, it is important for you and your peers and your organization to know exactly what those things mean for your context and organization. And in doing that, assume nothing. There is a danger that a consultant or an expert will come along and say, here's what digital means, or here's what cloud means. And there is a real danger in not asking the simple questions in such a way that you can translate between those ephemeral concepts, those high-level abstracted concepts, into real activity in terms of business planning and the creation of value. So it does come down to the simple things. At the end of the day, doing new things comes down to some mix of interaction between people, process, and infrastructure. We're all in an organization that's there to create value that somebody somewhere is paying for. Doesn't matter whether it's public sector, the funding model might be different, but if you're not creating value to the degree that somebody, maybe a government, recognizes that what you do generates sufficient value for them to be happy to pay for it, then surely that's what it's all about. So think first principles, not assumptions. Don't be afraid to ask these questions, and go back to the organization from your technology role and ask some simple questions like, how do we run the business? How do we change the business in an evolutionary way? And how do we transform our business? What are our markets, customers? What's our proposition to them? How do we generate value? What's the future of work, both now and obviously very, very relevantly at the moment in the future? And in all that, for the organization and context that I'm in, what's the importance of new things, innovation and technology? Is that core to what the organization's value generation is? Is it all about generating new things, or actually is it about making sure we're not deflected by new things and just do enough to keep up? No right or wrong answer, clearly, but definitely primitive questions to think of. So, and I'll be very careful here, because with absolute sincere empathy to those that have been impacted by the current crisis, and my family, unfortunately, is one of them, Winston Churchill once said, never let a good crisis go to waste. And I think for those of us that are working in technology in the area of change agents, disruptors in some way, now is the time when people are going to be ever more willing to listen to thinking about old problems in new ways, if you like. So look, these nouns have no ubiquitous meaning. be that one that asks those primitive questions. All organizations must now, if they didn't before, what their business is all about from first principles, not from just extrapolating the way that it's always been, but from first principles, from these things like value and meaning of work and what it's for. What's our business all about? And there's just never been a better time to question the status quo. So that's all from me. Hopefully that's been of some value to you, and thanks for listening.